last time we stopped here. I gave this example about food forensics, how we would use it to analyze. This slide is not in your packet. This is something I added. I just want to remind you, if you find slides missing or different, sometimes I update my slides. So you will find the updated ones on Moodle. Okay? So this is on Moodle already. So we went over this example. What we were doing last time on Wednesday, we were giving examples from a food industry perspective. Examples as to when you would analyze what and what would be the problem that caused you to think about analysis or different types of analysis. So we went over that. There is another example that we didn't go over, is industry competing. So there's a new product in the market and your industry wants to produce something similar, and how would you approach launching a product that is a competitor to another company? Yes, Nicole?
I would look at the ingredient list so you can see what order they're in, so you can tell what has the most of whatever in it, and then you can also analyze it for different components, like, or even look at actually there's a nutrition label provided with it usually, so you can look and see what the different components are, so you kind of reverse engineer what it is.
Very good. So the reverse engineering bit, that's, like I said last time, is going to be part of a laboratory that you're going to do next week. So one thing you would do is look at the ingredient, get a program that would help you plug in the ingredients and go backwards to get the formulation. And it would be just a guesstimate. It's never going to be the exact one. And then there would be, and you can go analyze it, like you said, or confirm with the nutrition label. So yes, so that would be your first approach. So if we want to look from a government perspective, so we looked last time from a customer perspective, from an industry perspective, and now from a government perspective. So there are regulations. Most of these regulations you're going to learn about in quality control class. But anyway, there are regulations for nutrition labeling, for example. How you analyze what you analyze and what goes on the nutrition label. This is the next subject, that chapter 3, that if I get through this today, we'll get to chapter 3, and we'll talk about nutrition label and how it's mandated and by what agencies it's mandated. So also you're mandated by the government to follow good manufacturing practice and also the hazard analysis critical control point, which is the HACCP. So these are stuff that you learn about in quality control course. So I'm not going to go over in detail, but basically you want to maintain a certain standard, certain quality, and you analyze for that during processing and at the end of processing as well. All regulations related, or government regulations or federal regulations, you can find it in CFR, which stands for? Yeah, if you want your 2 points, raise your hand and you'll get them when you answer. So, Code of Federal Regulations. So that's basically where you would find requirement for nutrition label. Any government regulation related to food, you'll find it in CFR. And then there's the Codex, which is for international trade. So you will find regulations related to international trade. So constituents, for example, if you want to export something that has GMO in it, it might be strict regulation for certain places in Europe, which is not approved to have GMO ingredients. So there are regulations for international trade, whether exporting or importing, and these are present in the Codex. So CFR and Codex will be good references for you when you're working on your project. So you would probably need to go find out, is my product has a standard of identity, and what is the standard of identity of my product? You will go search for CFR. And there is a list of products that have standard of identity that you will find in that project packet. Okay, so we looked at it from different angles, and now as a food analyst, keeping in mind everything, whether you are the consumer, you are the industry, or you are a government agent. So as a food analyst working for any of these entities, what do we need to know? So what do we ask ourselves for first question? Okay, so what type of analysis I have to do? So this can be related to the direct problem you have, or a research question, or a quality assurance question. So what kind of analysis do I need to do? Do I need to analyze free fatty acids? Do I need to analyze for protein content? What do I need to do? So I need to figure out the type of analysis based on the problem that I have or the question that I have. With every type of analysis, whether you're looking for glucose content or you're looking for oxidation product or whatever you are needing to analyze, there's going to be probably tens, to say the least, different methods. There's so many different methods and choices that you have. And we're going to learn about a lot of methods in this class in different chapters of the book. So you have an array of methods. How do you choose? What do you go with? So that's another thing that you have to figure out. From there, you figured out your analysis, you figured out your method. Then you have to take a representative sample. So let's say you have 100 tons of a product produced per day in a certain facility. How do I get a representative sample that would give me an accurate assessment of a certain quality? Okay? So this is chapter 5. We're going to learn about sample selection, and we're going to learn about how to prepare the sample for analysis, which is a very important. Preparation can skew your results and give you a wrong conclusion. So it's really important to learn that. After you decide on all of this and your samples are ready, you go and follow the protocol for analysis. And many of the chapters we will go over examples of different analytical techniques following various different methods. So you learn that throughout the semester. Then you've got your data. You need to analyze your data, determine variability, determine significant difference, and then interpret this data. So some of the data interpretation and analysis we cover in chapter 4. We'll talk about that next week. You analyze your data, you interpret your data, now you make a decision. Move forward with the production, everything is A-OK, or you figured out a way to compete, or whatever is your decision based on the data that you get. So you make a decision and there you go, or you make a recommendation to the people that would make the decision. While doing all of that, you need to keep government regulations in. All right. So if we step back and think about the type of analysis. So knowledge check. Type of analysis to be carried out is determined based on type of the product, health claims, or purpose. Ray, I know. That lady, I already know. Ray. You said E, yeah. All of the above. Anybody else have it? Yeah. And you are not Sven, you are John. Okay. You say F, John? Yep. So you don't like B for some reason. Okay. Say your name first, please. Agnes. Okay, I'm going to go with Agnes and Ray. It's all of the above. So basically, let's say somebody did not like B. Why? You're making a claim that you have high calcium, okay, or low sodium. You need to make sure that you're meeting that claim. If you're saying that it's 1/3% or 30% less fat, you have to make sure that your product is 33% less fat. So based on the claim that you're making, you have to make sure that you are meeting this claim. So yes, type of the product, obviously, what do you have at hand, what's the problem, that dictates what type of analysis you're going to do, and then we have a lot of examples today and during the semester about the different types of products, different types of analysis you would do. And of course, your purpose, what problem you have at hand, or what question you want to answer. It's all of it. Okay, so you decided on the analysis, now you need to choose a method. Like I said, there's so many different methods. So what will go into your decision of making a choice for a method? The characteristics of the method. In chapter 4, we're going to learn about specificity, precision, and accuracy. These are the inherent property of any method. So do you know what we mean by specificity? When I say this method is specific or non-specific, what does that mean to you, Aaron?
You're it's going to measure for one particular value or one particular protein or one specific parameter, I should say.
Very good. So let's say I'm looking for a glucose content of a certain food product. I don't go do a method that tells me the total carbohydrate, which was one of the methods that you'll be doing in the lab. So do we want to determine total carbohydrate in our product? Do we want to determine glucose? Do we want to determine reducing sugars, not reducing sugars? What are we determining? This is just one example. So do you know the difference between precision and accuracy? What does this mean to you, Sarah?
I guess like precision means like maybe a method isn't going to be exactly accurate, like you won't always get the right values, but it'll always be like very concentrated on values that it gets. You know what I mean? So like it's.
You're hitting around it, but you use the word that would belong to the accuracy. Josie.
I think accuracy would be like having a value that's really close to what you expected to get, but precision would be having like all the values of what like different tests being close together, but not necessarily.
Yes, excellent. So precision is when you run the experiment, usually you run it in replication. So 1, 2, 3, 4, 5 replications. So how close these replications are to each other gives you how precise is the method. And there are means to determine the precision, standard deviation and official variation. We'll talk about that in chapter 4. Accuracy, you're right, Josie, it's how close the value is to your expectation or the true value. And there are also means to determine that, and that will be covered later. Okay, applicability of the method. Okay, let's say I have only 2 milligrams, but the protein method that I'm going to do requires 1 gram. So it's not suitable. So I have to look for another method based on how much sample I have. And this is always, especially when you're doing research, for example, it's always a limiting factor, how much sample you have and how much does the method require. Reagents, you have the right reagents, how expensive they are, do you have the equipment, is it a liquid chromatography mass spectrometry method? You don't have a mass spectrometer, you want to send it out, how expensive it is, and so on. Usefulness, is it going to give you results within 1 hour? Is it going to give you results after 24 hours? Do you have the time to do that? Can you choose a method that is quicker? How reliable, how much you can trust the data? And do you really need to analyze this? You go like, do I really need this method? And then do you have the personnel that are experienced? Do you need training in a particular method? Or is it easy and anybody can do it? So, and how safe it is. Like for example, Kelda. Kelda is not really a safe method for determining protein. You have corrosive acid and bases that you use. Do you have the requirement to carry out this method in a safe environment? Objective of the method. Again, you select the method based on your final objective. For example, do you want to determine composition for nutrition labeling? If you want to do that, then you are required by law to use official methods of analysis. Official methods of analysis also, they have different, sometimes you hear that they are called primary, they are called definitive, they are your reference method. Official methods are approved by official agencies, such as AOAC, that's right. What does it stand for? Analytical? No? Yes? Well, there is Association of Official. And the official, there is O in there. It's not for the off, it's for the official.
It changed.
Oh, they changed it?
Yeah, it's a colorful question. It changed.
So what is it now, Chelsea?
What was it?
It was something weird.
Yeah, they done some changes to
So
it.
it's no longer AOAC?
Well, it still is, but what it stands for, they technically changed.
Yeah.
What the acronym
stop.
stands
Okay, please me, don't believe them. It's what
for. It's Association of Analytical Communities, because they're not just chemists.
Oh. When did they change that?
I don't remember, but it was a colorful question. This is why we do this.
Okay. But anyhow, it's official. So the methods that you use, the method that you need to use for nutrition labeling needs to be approved. That means they've gone through a long process of validation. And then once they're validated, they become official, and then they'd be required for a particular purpose. So, however, when you're wanting a rapid quality control method, you just want to determine acidity, for example, really quick during processing, especially online. You want to see you're extracting fat. You want to determine if the meal have less than 2% fat, you have achieved the extraction of fat. So you want something really quick. So there are methods that, like IR method, infrared methods. We call them secondary methods because they've been calibrated based on primary methods. So everything that you use, usually, for the most part, validated against a primary method. So that's why we call them secondary methods. Okay? And they're usually quick and are not really involving extensive procedure. A choice of your method is also based on the composition of the sample. And we learned that during, for example, fat analysis lab. So there are different methods that we do, and you'll notice that your results would be more accurate using one method versus the other based on the composition of that food product that you get assigned. So there are products that are really fat, high in fat and high in carbohydrate, for example. There are products that are low in fat, high in carbohydrate and protein. So based on where they sit in the chart, methods have been developed for different compositions. So let's look at an example here. So to extract and analyze fat content in a food product, high in carbohydrate and protein. Okay? So the main composition of that product, you have little fat and more of carbohydrate and protein. The sample preparation should include, take a wild guess. Okay, Aaron. A. You're Michelle? In the back?
Yeah.
Okay. F, B, and C. Okay, let's see. What other answers do you have? You're Christina.
A.
You're going with A, so you're with Aaron.
D.
Gosh. You're John?
Yep.
Okay.
That's right.
What did you say? I was focusing on your name rather than your answer. Huh?
D.
D. Yeah, that's the closest, yes. Okay. So let me say A, sometimes yes, sometimes no. Depending on the moisture content of your sample and depending on the method that you decide to follow. For example, if you want to do soft sift for fat extraction, you have to really have low moisture content because the solvent will be hindered by presence of water in this system. So sometimes, yes, you need to do that. So if the product is not really high in moisture, then you don't need to do that. If you're using Moginer, for example, one of the methods for fat determination, you don't need to use that. Okay, so acid hydrolysis, yes, because you have high carbohydrate, high protein, they might interact with the fat, hinder their extraction. So you really need to hydrolyze them, get them out of the way to extract the fat. And then most of the methods require solvent extraction. There are non-solvent extraction methods for fat. We'll talk about that and when we cover fat determination. But most of the time it's solvent, so you need an organic solvent to extract the fat and quantify it. So yeah. Okay, so you want to make sure that your method is valid to choose it, right? So you check validity, and there are a lot of things you can use to check validity. We talked about precision and accuracy. Specificity also depends on what you're really after. How variable, not just within replication. Sometimes the method, if you do it on a different day, ask Amy about that. If you do your method from a different day, different reagents, then you get totally different results. So Amy has to store all her samples and then analyze them all at once in one day with the same set of reagents. So this is something that one needs to consider. Also, can you take a representative sample, and we'll talk more about that in chapter 4, and how many samples you need to withdraw and analyze. Adequate procedure, repeatable results. Can you always get similar results no matter how many times you repeat your method? Also, to validate the methods, there are ways to do that. So you can get actually reference samples or standards from the National Institute of Standards and Technology. So they can send you a reference sample, and then you can analyze it with your method and determine the validity of the method. Also, there are sample services from AACCI, now there is an I for international, because it starts with American Association of Cereal Chemists. Did they change that too?
No, that was still the
But
same.
it has an I attached to it. Now, it's not only American, they put international at the end of it. And the American Oil Chemist Society as well, or Association of Oil Chemist Society. It's not American, I think it's the association. Anyway, so they have sample services. So they send you a sample, they ask you to analyze it, and then you send them the data, and then they compare it to their data and send you a report of how valid your method is. So you're going to use these references again in your project. So what I had here, I pulled up tables from the textbook itself, but when you search for AOAC, the newest edition is the 20th edition from 2016, and they should be available through the library online.
A tidbit of that, when you're looking through these methods, you have to be signed into the library's webpage. Otherwise, if you just put AOAC to go in, we don't have access, but if you log in through the library, then you'll have access.
Good. And sometimes they expire.
Yes, and so if that happens,
No, it's good.
Yeah.
she is checked.
Yeah,
It's good? Yeah. I think when Chelsea was a student, it was expired, and she had to contact them to renew their membership with AOAC. So, but anyway, so there are different methods, official methods for different products that you can search for different types of analyses. Also, there is the American Association of Cereal Chemists International, which I should update that, and the newest edition is from only 2010, but this is the latest edition that they have. It's the 11th edition. Also, there are mostly related to cereal food analyses. Okay, so any cereal food or ingredients, you can find official methods under this association. It's American, not Association. Oil Chemist Society, again, the newest edition is the 6th from 2013, and this is mostly for oil and oil seeds product and proteins extracted from oil seed crops. Last one is the American Public Health Association. You might also use that if your product is a dairy product. So there's also a list of official methods. And the latest one is actually only from 2004. So they're due for some update there, but it's the 17th edition. Okay, that concludes the introduction to the whole class. And then now the fun begins. If you want to think it that way. I want to make sure I'm still recording. Yes. A lot of the introduction information or the main ideas of the introduction in the first chapter of the textbook. I'm skipping chapter 2, which is regulations, because you're going to talk about that in a different class. So moving on to the third chapter in your textbook, which is the nutrition labeling. And this is the subject of your first lab next week. So we'll see how much we can cover, and if I run out of time, I'll just skip ahead to what you're going to do in the lab next week really quickly. Okay, start with a check. Knowledge check. All right. According to the FDA, Food Drug Administration, and do you know what FSIS stands for? If you have taken food quality, you might know this. Yeah?
Food Safety Inspection Service.
Yes. Food Safety Inspection Services, Nutrition Label Regulations, the following is true. Take a moment, read it, and tell me which one is true. Yes, Ray.
I think it's C.
Ray thinks it's C. Other answers? Michelle?
With H-E,
Michelle thinks it's E. And Agnes. What? D. So far we have C, D, E. Vaidehi? A. Perfect. Nobody wants to choose B? Anybody in the room wants B? You want B? Perfect. Thank you so much. All of these are incorrect. So these are all incorrect. Nutrition label is required. Now this was in 1973, the year I was born. But sorry, I shouldn't have said my age. But anyway, so no, it's changed now. Nutrition label is required only if a nutrition claim is made. That's also in 1973 regulation. Showing percent daily value for protein is mandatory? No, only if you're making a claim or if it's for children food or for athletes. Methods of analysis are to be determined by the manufacturer? No, they don't have that luxury. If it's nutrition label, they need to follow official methods. Stating percent daily value of vitamin A and B12 is mandatory. Vitamin B12, definitely not. Vitamin A used to, the regulation changed this year, and now it's dropped. So there is no more vitamin A requirement on the label. So, none of the above. All right, so the story about the labeling regulation. So you have the FDA, which is the agency that controls or regulates labeling, and for almost all foods. And then you have the USDA, FSIS, mostly control the regulations for the labeling of meat, poultry, and egg products. So together, they work together to have these regulations. So the regulations started as early as 1906 by the FDA Act, and then the 1938 Food, Drug, and Cosmetics, thank you, Act in 1938. But then they only required amount of food in the package, the common name of the food that you're consuming, and the ingredients. There was no specific nutrient information on that label. However, in 1973, they become an optional. In some cases it's optional, and in some cases it's mandatory. And then from there, so it goes that going with more regulations coming, I lost my words, but anyway, we went from ingredients to nutrient content. It went from optional and mandatory for certain products to mandatory for most products in the Act of 1990, Nutrition Labeling and Education Act, and this act gets amended. It got amended at least 2 times, as far as I know, if not more. Anyway, so I was saying that in 1973, it was optional to include nutrient content and nutritional value. So, but it was mandatory if you're adding a nutrient, like you're fortifying, you're adding, let's say, folic acid, or you're adding iron back to flour, then you should label that, produce a nutrition label. And back then, the concern was with micronutrients deficiency. So like deficiency in vitamins and minerals. So that's what drove the 1973 regulation to make it mandatory for when you add nutrients. And mostly it was micronutrients, vitamins and minerals. However, over the years, it changed. Instead of the concern, there's rarely deficiencies in vitamins and minerals, but now the concern became with calories and macronutrients, mainly like fat and sugars, saturated fat, cholesterol. So that became a concern. So the 1990 Nutrition Labeling and Education Act made it mandatory for almost all foods. Can you think of a food that is not required to have a nutrition label? Catherine.
Fresh fruits and vegetables.
Fresh fruits and vegetables.
Or they say the same thing.
Fresh fish.
Fresh fish, yes.
Oh.
Nicole?
Like raw ground meat at the store, it doesn't have a label on it.
Yeah. So there are certain, so you don't have to have a nutrition label for such type of food. And also eggs, for example, you won't see nutrition label on eggs. Sometimes if you have small packages within a big package, you won't see nutrition label on the small packages as well. So, all of the nutrition label regulation, like I said, can be found in the CFR, Code of Federal Regulations. All right, so up till this year, this was the nutrition label. This is how it looked like. Okay, so you had your traditional total calories per serving, calories from fat. You had total fat, saturated fat. This trans fat was added in 2003, so it was not in the original 1990. It was added later on because of the concern of processed oil and vegetable oil. What happens when you process vegetable oil? It's kind of called partial hydrogenation. We're going to talk about it a little bit more in chapter 14. But when you do that, you generate partially unsaturated fat in a trans configuration rather than cis. And what adverse reactions do you have? Kathy?
It's strongly linked to coronary heart disease.
Coronary heart disease, obviously. So yes, so it became mandated in 2003 to be included in the label. So, and from the micronutrients perspective, because of the historical deficiencies in vitamin A and vitamin C, they became part of the nutrition label, as well as the importance of those two minerals that people can still have deficiencies of up to this day, calcium and iron, so they're there. Any other vitamins and minerals are optional unless you're making a claim. Especially for vegetarians, for example, they don't eat meat. Sometimes they fortify cereals with vitamin B12, which you only get from meat. So you really have to put it, when you add a nutrient, you have to put it on the nutritional label. It's just from your table 3. Again, the components, other essential vitamin and mineral, this is optional. So it changed. It was proposed in 2014, and then it just got approved. This is what the nutrition label would look like from now on. So what happened is few bolding. They bolded the calories. It's like, okay, notice how much you're eating. So it's right there, bold and huge, right in front of you. So what they added too is very important, added sugars. So if you look here only dietary fiber and sugar, people want to know how much sugar you're actually adding to the product, rather than naturally present in the product. So they added that. And notice the major change in the vitamins. So no longer vitamin A and vitamin C. What you see instead is vitamin D, because up to date, people have deficiencies in vitamin D. No longer vitamin A as much as vitamin D. And vitamin C, which is really sad that they took it out, because there is a lab of vitamin C. And we usually use nutrition label to verify the effect of processing and change in the claim of the vitamin C. Because vitamin C degrades over time, and processing impact of that. So it's no longer there, unfortunate, but the lab is still there. We're going to continue with the lab for a while. One other important thing is potassium. So now, because of the significance of the health significance of potassium, it's added to the label. Okay? Everything else remains the same. You still have your saturated fat, your trans fat, your sodium. Yeah. Okay, this table is the daily required value for the different macro and some micronutrients as well. So you need to learn this by heart. No, you don't need to learn this by heart. It's FYI. Okay, now this you need to learn by heart. No, you're not going to do it. No, of course not, but this is a recommended daily intake of the different vitamins and minerals as well. This is FYI again. Now, if you have to believe me for this you need to know. For real. Okay, so here, what do you claim? So, less than 5 calories, you can express it as 0 calorie, for example. And then there's the rounding rule. This is important for your project when you generate your own nutrition information table. So you need to know how you can express nearest 5, nearest 10, when can you say it's 0 content, and the same for these components as well, the different types. Continues with sugar. Now you don't need to know this, but this would be a good reference for you to come back to when you're making your, working on the project. All right, so the caloric content. So how do you determine the caloric content? There are 2 ways, the most common ways that they do it. One is calculation, and the other one is also calculation, but they subtract the amount of insoluble dietary fiber because it's not digestible, we don't get calories from it. So instead of just accounting for total carbohydrate, they take the total carbohydrate, subtract dietary fiber, and then calculate the calories. So the gram of protein is equivalent to how many calories?
7. 4.
That would be alcohol, 7. Whoever said 7 before.
That's where my mind's at. It's Friday.
It's Friday. Where are you going after this? Let's see. 4. And then carbohydrate is also 4. I'll spare you about total fat. Jenny? 9. And alcohol is 7. We'll need that for one of the labs, so remember that. Okay, so you just get how many grams you have of protein and carbohydrate and fat. You calculate the calories, and sometimes you subtract the dietary fiber. And then this is how you have to differentiate between calorie with a capital C and calorie with a small c. When you see calorie with a capital T, it's usually it's usually kilocalories. Okay? And so when we say 4 calories, I mean 4 kilocalories. All right, protein quality. We're going to talk more about these different methods in chapter 15 when we do protein characterization. But you have to, if you notice, there is not always % daily value for protein on your label. But if it's infant food, you have to report it. If you're making on protein, you have to report it. So in infant food, there is a method called protein efficiency ratio method. We'll talk about that. It's an in vivo method based on using rat model. And the other one, protein digestibility corrected amino acid score. This is for adult food because the protein efficiency ratio method is equivalent to the growth of infants. So the growth of rats is equivalent to the growth of infants. So, yes, unfortunately, it's true. Do you know what the genetics percentage similarity between a rat and a human?
93.
It's about 90%. Some people say 93, some people say 97. Isn't that weird? Okay, we don't have a tail, that's for sure, so that's good. Okay, but anyway, so this is not usable for adults. This would be based on the digestibility by adults and also, well, adult rats in this case. But but there's also a second taking into account the essential amino acid or the first limiting essential amino acid. We'll talk more about that later. But okay, so % daily value for protein is found on the label of products. Go ahead. Tell me, Bailey. Okay.
I would say H.
B, C, and D, you got it from the first try. Okay, so we don't care, but we just get it obviously, and then we already mentioned health claims for athletes and children. Yeah, so good. Compliance is a big thing because oftentimes you get audited. So if you're in an industry and you're producing a product and you're sticking a nutrition label, you get audited by government to make sure that what you're claiming is what is exactly in the product. And then you need to be in compliance, otherwise you're in trouble. So, to be in compliance, you have, like I said, to use official methods of analysis to determine the composition of the nutrient content. So we already talked that. You have the AOAC, you have the FSIS methods as well, and these will be helpful to know for your project when you are developing the project. So level of compliance, this is also important, okay? This is really important table to know these values. So if you're claiming that you added a nutrient, whatever you added to your product, that's vitamin C added to juice. So you have to have, or vitamin D even added to juice, or calcium added to juice. So you really have to have at least 100% of what you claim. If you have less than 100% of what you claim, you're in trouble, you're not in compliance. However, if there are naturally occurring components or nutrients, you don't have to reach 100, but at least 80. So equivalent to 80 or above. But for the troublesome ones, the calories, the sugars, fats, saturated, etc., those that you are concerned about, they shouldn't be greater than 120% of what you're claiming. So these are the troublesome ones, so they shouldn't exceed 120. The regular ones, you can have 80 or more, and the ones that you claim, at least 100% of what you claim. So you have also, you can make nutrient claim. 1/3 less fat, reduced fat, calorie-free, 1/3 less sugar. So you have reduced, light, lean, low. You have so many different acronyms, or not acronyms, claims that you can make for a nutrient content. So, but there are rules. When can you claim free, when can you claim low, when you can claim reduced. This, not for you to memorize, but you'll need that when you're generating your lab report for the first lab. You're going to create a nutrition label, and you're going to, and there's going to be a question asking you, what can you claim? So you can going to look at your, what you have, the levels that you have, and then you're going to see what you can claim. For sodium, for calcium, for protein, what can you claim? For calories. So this is the table in your book, so it's just a reference to use to help you with your lab report. So this goes on, it just keeps going on. But also there is a long list of health claims, and this is a College Bowl question. By the way, we're recruiting for College Bowl, right?
Mm-hmm.
Yes.
We need
undergrads.
We need undergrads.
It's really fun.
It's fun, it's competitive, you get chocolate.
Yeah, of course. Chocolate, food.
Chocolate food, you learn more, here I'm recruiting, you learn more about your major, and you compete with other students from other programs, and we get to go to nationals and compete, and we have won multiple times regional, and we reached to national, and this next year is going to be here.
Yeah, it's going to be here. Competition is in April. It's a lot of fun.
Yes, if you are a competitive person, if you like games, if you like to learn more about your major, like to social, like chocolate, come.
Well, we got students too, but we really need undergrads. So
Yes, we are,
everybody's welcome.
because the rule is you cannot play unless you have 2 undergrads on the team, at least 2 undergrads on the team. We have a lot of grads, but we need undergrads.
Mm-hmm.
Anyway, but going back to this College Bowl question. So there are so many different health claims. This is just an example of so many, and they're listed in your book. Actually, maybe the book that you have right now is not most updated. Next year we'll have a new edition with most updated claims. But yeah, but these are approved, officially approved. You cannot make a claim unless it's approved by the FDA. So these are approved claims based on so many years of research that's been done to link a nutrient to a health issue. Okay? So many research based on human research, not just animal studies. In order for something to get approved, it's a long process. Okay, I'm so happy I got to the end. I didn't know that I'm going to get to the end. Do you have any questions before I talk about the lab? Anything at all? All right, so next week, what we're going to do is, first of all, I'm going to go from anywhere here, not necessarily. We're going to meet in ABLMS 135. The actual carry out of the lab will be in the computer room, but I want you to meet me in in the ABLMS lab. I'm going to go over lab requirements and lab reports and all that fun stuff about lab. And then we're going to walk to the computer room and you carry out the experiment there. All of the lab coordinator, Cindy, was here. She had to leave for an appointment. And then our wonderful TA, and Chelsea is our lead TA for that lab. So we're all going to be there to help you out with it. So what you're going to do, you're going to, I think it's version 6, I updated.
Version 4.
It's still version 4?
Yeah.
I thought they
Like 4 point whatever.
Yeah.
They have numbers in
Oh,
it.
okay, so ignore that. What you have here is correct. I thought in 2014 it was version 4, and now that I didn't teach in 2015, I thought we jumped to 6. But
Yeah.
all right, forget it. Anyway, whatever the version is, you're going to use with the Tech Wizard. You're going to generate nutrition label for yogurt. You're going to see how when you change formulation, how does the label change? How do you do reverse engineering? And then you make a nutrition label for a chocolate cookie, which is cool. Anyway, so what I want you to do is read chapter 3, review the notes here, and then you have a first addendum in your laboratory packet. We're not going to use the lab manual, we're going to use the lab packet, and the first addendum in your lab packet is what you want. And Cleanup Quiz is already uploaded on Moodle under lab folder. So you go in and you download that, and you do it over the weekends. It's really very short, it might not take you more than 10 minutes to do, but this will at least get you familiarized with what you're going to do. And you turn it into your TA, either Monday or Wednesday. Bring a lab notebook with you, don't forget. We're going to go over that in lab. And there are a bunch of lab handouts. One important one not to forget is your lab report format document. We're going to go over that. So it's in Moodle as well, and also in your packet. You'll find in your packet. Come on time. There's a lot to do. Lab starts at 9:35 in the morning. Please be on time and have a wonderful weekend. All right, see you next week.